discrete random variables, example 8. Before I start actually doing example 8, I'll just give a brief overview of the discrete uniform distribution. Uniform means that all the probabilities of each outcome are the same. So for example, rolling a fair dice, you would get 6 outcomes, and each one will be equally likely if the dice was fair. So we would say it's got a discrete uniform distribution, and each value is it's got a probability 1 over 6. So if there were n values, then you would expect each one to have a probability 1 over n. If there were 10 values, it'd be 1 over 10. If there were 20, it'd be 1 over 20 for each entry. Now, there are two results that you don't have to actually be able to prove, but you do need to learn them because it makes it much quicker for you in the exam. This is the mean. That formula is only true for a discrete uniform distribution. Only the probabilities are the same every time. And similarly, this formula for the variance is only true if it's a discrete distribution. So don't try and use these formulae for other distributions. Okay, so example 8, we've got a probability density function where the probabilities are equal to 0.1 for each of the values 1 to 10. In other words, what that means is that if you were to fill in a distribution, you've got the values 1 to 10, maybe it's a 10-sided spinner, and each one has got a probability of 0.1. So let's quickly fill those in. Okay. Part B says sketch this using a diagram. Now this doesn't come up very often on the exam, but I just wanted to make sure that we covered it. So I've actually pre-drawn this at the bottom. Each discrete value, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Each one has a fixed probability of 0.1. We can't draw it as a solid block because it's discrete data, so there has to be gaps in between, in the same way that you have gaps in between on a bar chart. So that's what a diagram would look like. Again, it doesn't really come up on the exams very often, but just in case it does, you know what it looks like now. Okay, to work out the mean, we could do 1 times 0.1, 2 times 0.1, and so on, and add them up in the usual way. But remember, we have that formula which makes it so much quicker. N is the number of outcomes, that's 10. So 10 add 1 is 11, divided by 2, the mean is 5.5. And you would expect that because it's slap bang in the middle. The variance of x, remember that formula, n squared minus 1 divided by 12. N squared is 100, take 1, 99, and divide by 12. You could leave it as 99 over 12, or you could write it as a decimal if you want to. Again, you could do the standard method for working out the variance, but I think you'll agree that that one's a little bit quicker.